Alright, so number 9 for this homework, we're working with cube roots or something to the 1/3 power, expression to the 1/3 power, and solving those equations. First thing is we're going to isolate the radical, so subtract 5 from both sides. So that leaves you with negative cube root of x minus 4 equals negative 3. We're going to divide by negative 1, so that's going to get rid of the negatives. And then we're going to take the cube both sides to get rid of this cube root. So we're going to cube both sides. I'm going to put a 3 right here and a 3 right there. So that leaves me with x minus 4 equals 27. I'm going to add 4. So x is 31. Okay. Quick check, 31 over here. 31 minus 4 is 27. Cube root of 27 is 3. 5 minus 3 is 2, so that checks off. Alright, so for number 10, we have the cube root on both sides, so they are pretty isolated. I mean, there's nothing else we can move or change sides, so we leave it as it is, because we have one radical on each side. So now we're going to take, or cube the two sides to get rid of that radical. So we cube, and then we cube. So on the left side, we cube the 2 because notice the 2 is outside, so we have to cube it. So that's 8. And then the radicand comes out. And on the right side, we're left with 4x minus 9. So now we've got to distribute the 8. So that's 24x plus 16 equals 4x minus 9. Subtract 4x. Subtract 16 from both sides. So you have 20x, cancels there, that's gone, negative 25, divide by 20, we can reduce by 5, and so that gives me x equals negative 5 over 4. Okay, so for 11 we're going to do the same thing. The radical is isolated and we want to get rid of it so that we can solve for x. So to get rid of the radical, we have to, since it's cube root, we're going to cube both sides. So on the left side we put a 3 here, we're cubing it. On the right side, don't forget to put parentheses because everything on the right side is cubed. And so remember, this means x plus 5 times x plus 5 times x plus 5, 3 times because of cube up here. Okay, so we're going to multiply 2 at a time. So this is x squared. Well, let me simplify the left side. So on the left we get 69x plus 35. On the right side it's x squared plus 10x plus 25, and we still have to multiply the other x plus 5. So you could either make a little 2 by 3, and so you put x plus 5 here, and then x squared, 10x, and 25, and we're multiplying. So this is x cubed, 5x squared, 10x squared, 50x, 25x, and 125. So we're going to have 69x plus 35 equals x cubed, and right here this one and this one are like terms, so that gives me 5 and 10, that's 15. And then this one and this one are like terms, so that gives me 50 plus 25, that's 75, plus 125. So I'm going to subtract 69x from both sides and 35. 69x and 35. Simplify this, combine like terms, so that's x cubed plus 15x squared. And then we have plus 6x, and then we have 90, plus 90.
Your number?
Yeah, number 11. And so we're going to try factor by grouping, and the way I set that up is put the 2 by 2, put your terms here, and see if that works. 6x and 90. So the greatest common factor in the first row is x squared. So x times x squared is x cubed, 15 times x squared is 15x, and 6 times x is 6x, and 15 times 9 is 90. So this works. What this tells you is that x plus 15 is one factor and x squared plus 6 is the other factor. Okay, so we're solving for x. X for the first factor, x is equal to negative 15. For the second factor, it equals an imaginary number. And for this problem, we're only worried about, or we're only looking for real numbers. So the only answer here, because again, this one's going to give you imaginary numbers, two of them, plus or minus square root of 6i. The only answer here is this one. Alright, for 12, the radical is isolated, so now we just have to raise both sides to the third power to get rid of the radical. So we're going to raise this to the third, and then on the right side, don't forget parentheses and third. And just like on number 11, x minus 1, that quantity to the third power means x minus 1 times x minus 1 times x minus 1. Okay, so on the left side we've got x plus 3. On the right side you multiply 2 at a time, so that gives you x squared minus 2x plus 1. And then don't forget you still have that x minus 1. Okay, so now I'm going to multiply into a 2 by 3. So that gives me x minus 1, x squared minus 2x and 1. When you multiply, you get x cubed minus x squared minus 2x squared plus 2x, x, and negative 1. So combine like terms, this one and this one. So that's going to give you on the, okay, x plus 3 equals x cubed minus 3x squared. And then this one and this one are like terms, so that's going to give you plus 3x minus 1. We're going to subtract x and 3 from both sides. So now we have 0 equals x cubed minus 3x squared plus 2x minus 4. Alright, so again, I don't know what's happening with the 3's and the 5's. I'm confusing. I'm putting 3 when it should be 5. This should be a 5. And so that means this is a 5. And so these two are 5's. It's going to make a change in my final answer here. This is a 5. So then this is going to be a 6. So the right side is all correct. It's just I wrote the problem wrong. I wrote a 3 instead of a 5 in here. So when I moved it over to this side, it was giving me the wrong number there. But the right side is all correct. So now I'm going to try factor by grouping. Again, making a 2 by 2. X cubed minus 3x squared, 2x minus 6. Greatest common factor in the first row is x squared. And x times x squared is x cubed. Negative 3 times x squared is negative 3x squared. And 2 times x is 2x. And then you always check, is negative 3 times 2 equal to negative 6? The answer is yes. So it's factored correctly. So now you have 0 equals x minus 3. And then the other factor is x squared plus 2. So this one is going to give you x equals 3. This one's going to give you two imaginary numbers, right? Because when you solve for x, and you take the square root, this is going to give you an imaginary number. So the only solution to this equation is x equals 3. Alright, so 13, we have both sides raised to the 1/3 power, so we want to get rid of that 1/3. We're going to raise both sides to the 3rd power. So 3 and then 3. So by doing that, what we have done is we've canceled the 1/3. So 1/3 times 3 is 1. So the left side is x plus 7, the right side is 4x. So now we just subtract x, and so 7 equals 3x. We divide by 3, so x is 7/3. Alright, so 14, it's raised to the 1/4 power. So again, to cancel the 1/4, we're going to raise both sides to the 4th power, because that would give us 1/4 times 4 is 1. So again, remember, both sides to the 4th power. So on the left side, we're left with 5x plus 1. On the right side, it's going to be 256. 4 times 4 times 4 times 4. 4 to the 4th, 256. We subtract 1, so 5x equals 255, and then we divide by 5 to leave x by itself. So now x equals 51. Alright, so 15, we want to get rid of that 1/3, okay, to be able to solve for x. So we're going to raise both sides to the 3rd power. Remember, on the right side we add parentheses and then 3rd power. So we have negative 9x minus 54 on the left. On the right, remember what that 3rd power means with the binomial. It's negative 2x plus 3, negative 2x plus 3, and negative 2x plus 3. So when you multiply these two together, you get 4x squared, and then again, using the distributive property, minus 6x plus 9. And then don't forget, there's still a negative 2x plus 3. Okay, so this gives me 4x squared minus 12x plus 9. And then there's that negative 2x plus 3. We're going to multiply. So this is negative 2x and 3 here. 4x squared, negative 12x, and 9. So negative 8x cubed when you multiply, because remember we're multiplying. 12x squared, 24x squared, negative 36x, negative 18x, and 27. So we're going to add like terms as we write it down. So this one with this one, those are two like terms. So we have negative 9x minus 54 equals negative 8x cubed plus 36x squared. And then negative 36 and negative 18x are both like terms. So it's going to give me negative 54x plus 27. So now I'm going to add 9x and 54 to both sides. Okay, on the left side we have 0, negative 8x cubed plus 36x squared, then negative 45x, and then positive 81. Alright, so 15 presents a problem because it does not factor with grouping, and it doesn't have a rational 0. Okay, there's a typo in the problem, so this one you would need a graphing calculator to solve. Okay, so you would not get something like this on a test or quiz because you would need a graphing calculator, and we haven't gone through that process. Okay, so 15 will stop here because there's nothing we can do by hand. We need a graphing calculator. Alright, so 16, it's raised, both sides are raised to the 1/5 power, so in order to get rid of the 1/5, we're going to raise both sides to the 5th power. So here 5, and then here to the 5th power. So remember, we had another example similar to this, where there's an outside number, so the 2 right here has to be raised to the 5th power. So 2 to the 5th power is 32. And then